Hello, everyone. So today I'm going to be talking about Singularity. Version 3.5 is the latest version, and that's what's installed on the Compute Canada clusters. And I'm going to be talking about how to use it. I will do some overview slides first, and then I will give a demonstration of a couple of the features of Singularity, and you can see how to go about using it. So Singularity is container software. So if you've ever run a program called VirtualBox or any kind of virtual machine program or something that lets you run like an entire operating system in a window on your computer, or you've ever seen that, then that is close to what Singularity is. A virtual machine is a rather heavyweight kind of container because it simulates an entire machine. Now, there are lighter weight containers that don't simulate the entire machine. They rely on the machine that you're on for the main kernel, the booting up of that system and all that stuff, and all they do is they have all the software programs required. So it's almost a virtual machine, but it's not quite. Many people have heard of Docker. Docker is also container technology, so Singularity is another version of that. Singularity differs from Docker in that it's designed to be secure in terms of using it. Whereas Docker, when you run a program in Docker, there are more pathways to get to hack a system, I'll put it that way, to get privileged access that you shouldn't otherwise have. So Singularity, that's locked off completely because it does not rely on some of the things Docker relies on to run programs. So Singularity uses a secure single file normally for its containers, and that file can be encrypted if that is a need for you. And it allows for a reliably secure way to use containers on multi-user clusters such as our Compute Canada systems. Users can have full control of their environment inside the container, and it's a great way to package scientific software and deploy it to different clusters, because inside your image, the configuration of all the software tools can be identical. It can also be handy to run old software. There was one user I helped once, and they had software, but the software hadn't been updated in a number of years, and the newer software on our clusters was incompatible with it. So I set them up in a Singularity image and installed the older software tools, and that way everything in the image can run using the older software tools. Usually that's not the problem. Usually the problem is sort of the other way around. Some users want to run newer programs and what's available in our system, or they want to modify some of the program settings, or they want to do something that otherwise doesn't work well with our system. So Singularity is a solution for those users. So Singularity is similar to a virtual machine, but it's not quite a virtual machine. It has less overhead, and it can only run the same operating system inside the container. So our clusters run Linux. That means all the Singularity containers used on our systems have to run Linux. It doesn't matter which distribution you run, but it needs to run Linux. They accomplished the virtualization without using a full-blown virtual machine by using a feature in Linux called control groups, or C groups, and namespaces, and they use a special overlay file system to create the effect of what otherwise looks like a virtual machine, even though it's not fully a virtual machine. It allows you to separate things for security reasons and usability reasons, so that things running inside the container are running inside the container, and they can't see outside the container unless you allow them to. Now, as I mentioned earlier, Docker is another container technology that's quite popular, and a lot of people like to use it. There is a way to make use of Docker containers in Singularity, and I will show some of that today. But we do not have Docker on our clusters, and it will not be on our clusters. You'll need to use Singularity to run Docker. So if you're using Docker and you have a certain configuration you like, perhaps it's on your own system, you can take that. If you push up your image to Docker Hub, for example, you can actually use Singularity to pull it down from Docker Hub. There are other ways to convert your image. I'm not going to talk about those. The easiest one is to use as Docker Hub. So for Singularity, we already have it on our systems. So if you want to use it, you can use it on your own computer or any computer that's running Linux. Obviously, to install it, you'll need super user on that machine. But if you have Linux installed somewhere, you can install Singularity, and their website has instructions on how to go about doing this. On our clusters, using Singularity is very straightforward. If you're running Openmpi, if your program that you're using inside the container uses MPI, then what you want to do is, before you run any Singularity commands at the command line on our clusters, load Openmpi version 3 or higher. You need to have this outside of running things in the container, because MPI programs in the container actually invoke some components outside the container. So load version 3 or version 4, it doesn't really matter which. If you are using version 4 in the container, it is wise to load version 4. But it uses a feature, component of MPI called ORTE to take care of running things across nodes. If you're running everything on one node, then there's no problem. You don't have to worry about loading Openmpi at all. But if you are running things across nodes, running your programs across nodes, you must do this before you do anything else. Then load the Singularity module, so that'll give you access to Singularity. That's pretty straightforward. And the other things to be aware of, if you're using MPI, do not use MPI run or MPI exec in your Slurm JavaScript. Use srun. You must use srun. The MPI program in your container runs inside the container, but that MPI software will talk to the MPI outside your container, and the srun command passes special options and all that that enables that to occur. Okay, so if you see the line there, srun Singularity exec, etc., the srun command is running outside the container. The command I put path to your program, whatever that command is, that's running inside the container. So the two work together. So it's really important that you use srun to run your MPI code. Also, in my experience on our clusters, module load commands in Slurm JavaScript causes things to fail. So get rid of all the module load commands in your Slurm JavaScripts. Make sure you just module load those before you before you submit your job with SBatch, and SBatch will take note of all the environment settings. And the other thing you want to do is make sure that whatever you're running inside your container, this goes for all executables, but especially with Openmpi, make sure it was compiled and built properly using the tools inside your container, not outside. Some of the tickets with people having problems doing this is that that wasn't done. You have to make sure you build all the tools you're using inside the container with software programs, compilers, whatever they are, inside the container. Okay, so for images, when you want to use Singularity, what you need to do is you need to create an image. Okay, if you already have an image, awesome, then you're off to the races. But if you don't have an image, you need to make one. Very commonly, people will pull images from Docker Hub, but you can get images from other places, and you can even make your own. So for Singularity, the image will either be a file or a directory, okay, and they'll contain an installation of Linux. So you can create your images by pulling them from Docker Hub, Singularity Hub. There's also Scilabs has a library feature as well. Virtually all our users use Docker Hub or they're rolling their own. You can use a container image file that you already have. If it ends in .sif, that's for version 3 or higher. If it ends in .sqsh, that's for version 2.4 Singularity or higher. And .img was the original format, which is just an ext file system image. Now, version 3 can handle all of those files. All of these files, the SIF file and the SQSH file, when you use them, those are read-only. So when you're using it, the stuff in those files is read-only. You can't change it. If you do need the ability to read and write files, Singularity supports a Sandbox directory, and you can use that to do that, and I will demonstrate that today. You can also have a Singularity recipe file. That's not as useful for you unless you are rolling with shell scripts or other tools, and you're rolling Singularity images, and you want to produce images again and again by a recipe, a script, over time. So most users don't care to have that unless they're publishing something for others to use on Singularity Hub or something, or they're a Compute Canada support person and they want a script to regenerate a pristine image in a certain way with certain installed programs, etc. So, for example, let's say you want to build the latest 64-bit Debian image from Docker Hub. Now, on Docker Hub, the latest 64-bit Debian image can be accessed by accessing Debian. That's the URL at Docker Hub, Debian, for that. There are other URLs with Docker Hub, and you can get those from Docker Hub. In Singularity, what you want to do is you write a whole bunch of stuff in the line, but notice at the end of the lines there's docker://. So you just put docker:// and you put the Docker URL, whatever that is for the tool. Ubuntu is just Ubuntu. Debian is Debian, but there's all kinds of things you can use from Docker. Okay, so you build your image. What you do is you write Singularity, and then you say build, so that tells you you're going to build an image or a Sandbox image or a file. And then you give it a name. In this case, I'm going to build an SIF file, so I called it Debian from dhub for Docker Hub.sif. And then the last argument is the Docker URL. So that will build the SIF file. If you want to build a Sandbox directory, which you'll see why when I do the demonstration you'd want to do that in some cases, you need to put -s after build, and then you just specify a name after it, and that will make a directory, and everything will be put inside that directory. Now, there's one problem with all of this, is that all the permissions in the installation get flattened out to that of your account because you don't have any special access. So that means if you want to install software, you downloaded Debian, for example, it downloaded and it's being installed, now you had a problem. The problem is that apt, which is a tool used to install software, will not work because the command that will get output is that it requires privileged access. Okay, so what do you do? Fortunately, there is a solution. Okay, the first solution you can do is you could build the image on a machine where you have super user root access via sudo. You will not have this on our clusters. It has to be on your own Linux machine or your supervisor's Linux machine or something to that effect, or Linux machine running in a virtual machine. So if you have VirtualBox on your computer, you can install Linux in it, and you can put Singularity in, and then you can build the image. Okay, and then you can upload that file to the Compute Canada cluster and use it. So this may or may not be an option for you, or it may be too complicated or too much, etc. If that's the case, no problem. You can submit a ticket to us requesting help from Compute Canada to build your image for you. to run stuff in the image, you don't need special privileges. You only need that, in some cases, to build your image. And the third option is you can get away with using some distributions that can tolerate not having privileged access to install software in a flattened environment, and I'll show you some of that today. That said, for many that will be too complicated. Submitting a ticket asking for help will be the best solution of these. If you do have your own Linux machine, you use the same commands, you just have to put sudo in front because you have to be super user to run it, and that will avoid flattening out all the permissions and will allow you to do things that you need super user access for within the image. So using Singularity, there's a number of ways of using it. You can use it as a single command, runs the program, stops running it. Awesome. Okay. But in other cases, you might need a program to run as a daemon. It could be a small SQLite database server. It could be a little web server and things like this, and you run them. Different tools require different things. People say, oh, well, compute cluster running a web server would be very unusual. Yes, it would be. But there are some cases where that's needed. Increasingly, Singularity is putting in features that effectively firewall the container from others accessing things as well. These things are starting to come in over time. So if these are concerns of yours, then you can submit a ticket and we can interact with you and deal with these concerns. But one way or another, there's daemons sometimes you need to run. And what that means is if you just run one command and in the single command way, that would run the daemon and then stop, and that would cause the daemon to get killed, which would be really bad. So daemons stay running. So you run the program, but they stay running, and you need to keep them alive somehow. So what Singularity does, because it's designed to be used on a compute cluster, is you create an interactive session with a name. And then you say with that session, run this daemon or run this program, and you can run all kinds of them. And then when you're done, you can say stop running, and it will kill everything that's running. So if you didn't properly shut them down, it will kill them all. Also, if your job gets killed by Slurm when you run your job because of whatever reason it's getting killed, it will kill all the daemons running as well. So this is great. There's no hung processes and all that, and things can run nicely. So to run one command, you just go Singularity, and you can put exec. You can also put run or shell there. Well, exec or run will just run one command. You have to put your image file, okay, and then you put the command you want to run. So if you want to run GCC, which is a compiler, you get the version, you put GCC-V. So basically, you put what you want it to do. Singularity is the command. You put exec, you're saying run this one command. Then you put where your Singularity image file is. You put that. And then after that, you put the command you want to run, and then it will literally run that command. Okay? If you do it with the run command, it'll do the same thing. If you want to use the Singularity interactively, do things inside of it, not just run one command, you can put shell, and that'll let you run things interactively, and when you're done, you type exit. Okay? So interactively is obviously you typing commands and that, but if you're running Slurm and submitting a job with SBatch, you'll use exec or run. If you're using SBatch and you need to start daemons, then you want to start an instance. So it's special because you have to start the instance. So you put Singularity instance, start, the image name. Yes, these things get longer, but fortunately not that hard to use. And then you put a name that you want to call this. So you have to give your instance a name. So I put my job here, whatever name you want to use. Okay, and then you can see the instance running. Well, the instance available, you can go Singularity instance list, and it'll list the instances, and then we'll list all the programs and their process IDs that are running. So here's a full example. Suppose you want an instance called 1, Singularity instance start image, some image file, and then 1 is the name of it. So then I can use exec to run a program or a daemon or whatever I want, Singularity exec, the image, and you have to put instance : / and then the name you gave it, so 1, and then you put the command you want. Now that command could be a daemon, okay? That would be fine. Then if you wanted to do something interactively, you could do Singularity shell, etc. Notice instance : / 1 is required each time. Within that, you could run some commands, okay? And these commands could run in the background in that. You'd be okay. You could type exit, and you could run more commands. So you can just keep doing this, and they all run within the same instance. You can think of this as if they're running on the same machine, really. And when you're done, you can tell it to stop the instances that you've run. You just go Singularity instance stop, same image file, and then you just put the name of the image you want to stop. Now, as you'll see when I do the demonstration, when you run a program inside your container, in a sense, you should think of these programs, they're running like in their own machine. They happen to be inside the machine you're on, but they're sort of running in their own machine. They don't see files outside of the container other than your current directory and your home directory. So outside of that, you need to tell it you want to access other parts of the file system. So with Singularity running on our clusters, you very likely want to be able to access files in home, project, scratch, or local scratch. So if so, you need to put the -B for bind mount to mount those directories so you have access to them. You only have to put the top level directory. So if you have a variety of people in your research team and you share some of your disk space across project, -B and then saying /project is sufficient to have access to the project directories. Basically, if you have access outside of Singularity already, you'll have access inside by putting that -B /project. Okay, so that's how it works. When you run stuff, you can put -B and then you'll have access to various parts of the file system. It's very common, especially to access things in project and or scratch. This is needed if you have large files, for example. Now, it is possible, some users need this, so I mentioned this. It is possible that anything you use with -B to bind mount a directory, you might want that in a different location inside the container. You can do that by going -B and whatever directory you want to mount, put a colon, and then you can put where you want it inside the container. So by default on our clusters, the temporary directory /tmp is in memory. This might not be a good thing. There are some programs that want temporary to be a hard drive because they write many gigs or hundreds of gigs of temporary files and things like this. And if that's in memory, your job will get killed. You'll use all memory. So to avoid that problem, you can use the -B bind mount to mount a specific directory of your choice wherever you want it. Then you put colon, and you put /temp, and inside your container, the temporary directory won't be RAM anymore. It will be whatever that directory is that you specify. You probably specify somewhere in local scratch if you're doing that, because you probably don't want your quota to kick in on that. You probably just want the temporary space available through the local scratch mount, and so you can write all those files and you don't have to worry about running out of memory. So that will get you out of a bind there, using the bind mount, but remapping the directory name. If you don't specify colon and where you want it inside the container, it will mount it at the same location inside the container. So now I'm going to do a demonstration. Of using Singularity, and then when we do that, you're going to log into Graham or Beluga or Cedar or Niagara, whatever the cluster is, and you'll make a directory. If you're doing a lot of Singularity work, you might prefer doing your work in Scratch. But for today, I'm just going to do it in my home directory. But if you, Singularity images, some of them can be quite large, many gigabytes in size and stuff, and some of the intermediate files can use up a fair bit of disk space. And if you already have a lot of files in your directories, you might prefer using Scratch because you won't have to worry about running out of disk space, and you can use it, more space is available, and you can get your image. And once you have your image file, all that, those temporary files aren't needed anymore. So when building an image, there's all kinds of temporary files created, and the disk space increases substantially. The other thing that can happen when building an image is you can run out of memory. With the newest versions of Singularity, these memory problems are becoming increasingly resolved. But if you do run out of memory and you just can't build the image, submit a ticket asking for help. Okay, so now I have a directory here, Debian from dhub. I'm going to leave that there. I'm going to run this command live, and if it takes too long, then I will just use the results of that, which is what's in Debian from dhub. Okay, so what I'm going to do is the first thing I need to do is I need to do module load Singularity. Okay, and I'm going to load version 3.5. There we go. So now if I do module list, you can see that I have Singularity version 3.5 loaded. Okay, when I demonstrate stuff today, I'm not going to use Openmpi. That's why I didn't bother loading Openmpi. But while I'm here, we will take note that GCC is version 5.4.0. Okay, so we're just going to take note of that. And we can note some other things. So when I'm logged in on Graham, nothing special. I just logged in and went into this directory. All the modules are loaded, are the default ones, and I just loaded Singularity, but by default, version 5.4.0 of GCC is loaded. Okay, awesome. So now I loaded Singularity. I don't have any special user permissions. I'm using the Compute Canada cluster right now. So I'm just going to use Singularity, okay, and I'm going to build. Now I have two options here. I can build a file, or I can build a directory. Let's build the file first, okay? So let's call this debian.sif. And since a lot of people use Docker, let's grab what we can get from Docker. So I'm going to build the latest Debian image. The Docker URL is just Debian. So if you build your Docker image just using Debian, fine. If you build it with Debian : and some other things, put Debian : and some other things. Okay, so I'm going to hit enter on this. And what it's going to do is going to say starting build. It's going to download some stuff. It's cached it in my account because I did this once earlier today, so it would cache that. We wouldn't have to wait for the downloads. And notice the errors we're getting here. Warning. And XHETR, it's talking about file system permissions. And it's not able to set those settings because we don't have super user access. So when you pull down an image from Docker like this, and you're not using sudo, and you're on a system, you don't have sudo, so you're not using any root access, what happens is everything in the image gets flattened out to your user permissions. So whatever your account is, so my account is my last name, Preny, P-R-E-N-E-Y, all my permissions for all the files, everything in this debian.sif file will be set to my account's permission. That's all there is to it. Now, what I'm going to show you shortly when this finishes is this is okay. You can run stuff in the container, and if you download the container from Docker Hub and it has everything that you need installed, nothing else needed to be added to it, then happiness. You'll be able to run your program. But if you need to install software, this is Debian, Ubuntu the same, you'd use the apt command to install software, you're going to see that won't work. And that's because the dpackage command, which apt uses, requires super user permissions. Okay. Now, this delay right now is we're waiting for it to write to the file system, the image. And it's actually building the image from a bunch of files. Docker uses layering. It takes all those layers and puts them together and rolls them up into one image. So you can see it can take a little bit of time. Another reason to use Scratch is faster than Home or Project. So this would have been a little faster if I was running it in Scratch. Okay, so it just built the file. So if I do an ls-l, we can see that we have debian.sif, and I put an LH there, and this will tell us, and that image got compressed. One reason why it does take a little bit of time, it does compress the image, and it's compressed to fit in 46 megabytes of space. So this is a very minimal Debian image. But I got it now. Okay, so now I can actually use it. So let's try doing something, and let's use it interactively. So I can put Singularity shell debian.sif. Okay, the shell is for interactive use since I'm typing at the keyboard. This works. Okay, and then you see a prompt, Singularity. Now this is a shell right now. I like to type bash to see the prompt of that Linux distribution, but you don't have to. And I will just get out of there with exit and just stay at the prompt here. Now, something I want to show you while I'm here. Okay, so if we do cd/, okay, and I do an ls, there we go, we do ls-l, you can see we got some contents in this directory. Okay, you'll see environment, okay, and Singularity, those are special, okay, and then we have the usual suite of directories. That's interesting. Let's leave this container. I'm going to type exit, and let's go to cd/ on the cluster. Actually, let me just run a shell so it's easy for me to get back there. And then cd/ on a cluster, the cluster. If I do this, ls-l, there's more directories here. There's archive, there's cvmfs, there's local scratch, okay? There's all kinds of stuff, and there's no Singularity thing, and there's no environment thing. And if you do an ls-l, you'll see it's different, okay? So understand that when you're inside, running programs inside your container, what you see as the file system is not the same as what you see outside the container, okay? So I am on Graham right now, and you can see my login prompt, login tree, and these files that you normally see when you log in, when you go into the container and you do the Singularity shell, okay, you don't see the same files. So you would say, oh, interesting. So because if I go to my home directory, okay, try this right here. Okay, so I just went to my home directory, and if I type ls, I'm inside the container right now. You can see that because of Singularity. And I got my projects. Okay, so I go in there, got things here, and this goes to project. Now, if I try to go to def.prenny, no such file or directory. Why? Well, because inside the container, there is no project directory. You can see here, we go from opt to proc to root. This is sorted, so if project was here, it would appear there. There's no project directory inside the container, okay? So unless you bind mount the directories you want, you won't be able to access them, okay? So you should think of your container as everything in it should run with whatever's inside of it. If you'll need access to your files, because that's maybe where you're storing your output files or your big input files. But everything that the program needs to run in terms of executables and config files should be installed already in your container. So this way, you only have to mount those other places so you can access them. Now, I should point out that Singularity by default, okay, if you are running Singularity shell or anything like that, Singularity by default automatically bind mounts your current directory. So if I do Singularity shell again here, and I just say, what is my current directory? Okay, it gives me that current directory, and it'll always show me my current directory. So if I were to get out of there with exit and go to project, for example, so I'll just do that in this way, go back to my home directory and go to projects. Okay, my project directory, I'll go one more in. Okay, so I got a bunch of stuff here. Okay, if I were to run Singularity that was in that other directory, so Singularity shell, now I have to put my whole directory, Singularity presentation, debian.sif. Okay, if I do that here, and I type pwd, it's actually in the same directory, and I can see the files in it, okay? Because Singularity will always mount the current directory. So if you only want access to the current directory, regardless of whether you're using shell, run, or exec, all you have to do is cd to that directory before you run Singularity, and your Singularity programs will be able to access the current directory. Okay, I'll get out of there. Let's get back to my directory here. So this is interesting. Now, let's do something. Let's try to run Singularity shell Debian, and let's try to install something. Apt update. Okay, we can't, and it says read-only file system. Okay, that's because all the .sif file and the .sqsh files are read-only. Okay, so if you actually want to modify the image, you have to do it using a Sandbox directory. So let's try that with Debian. Now, the command to do that is almost the same. I built that image with Docker using this line. If instead, to make the Sandbox, you go -s, okay, and you call, I don't know, called it Debian-Sandbox, and if I hit enter on this, okay, I'll hit enter here, but I'll Control-C it because it'll take longer. Okay, what it will do is it will put the files inside this Sandbox directory. Okay, and so it makes a directory and then puts the files inside. Now I'm going to Control-C this right now. Hopefully it stops soon. There we go. Okay, so it cleans up itself after itself, which is nice. The reason Control-C'd it is my Debian from dhub directory is the result of that. Okay, now notice this Debian from dhub directory. I don't have super user permissions here, so it has my permissions here. Okay, fine. If I go inside of it, everything inside of it also has my permissions. Okay, so no matter where I go in this, everything has my permission, permission set. Now, that will allow me to modify things. So let me go into Debian from dhub, and let's just take a look at the files in here. Okay, we have these in here, and I'm going to make a file called myfile.txt, and I'll just prove that to you here. I'll put myfile.txt here. Okay, and there's nothing in that file, and I'll just do that right here so we can see myfile.txt right there. Okay, that file has my permissions. Awesome. Okay, so then you'll say, well, how do we use it? We just have to put Singularity. We'll use it interactively, and we'll put, when you're using a Sandbox directory that has all your permissions, put -w, or anytime you want to be able to write to it, you have to put -w. Okay, and then you put Debian from dhub. Okay, and that's it. So you put the directory name. Okay, and the contents of that directory is actually what's in the .sif file, except the .sif file is compressed. So if I hit enter here, it'll let me in. Cool. Okay. If I go to the root directory and type ls, notice what's here is myfile.txt. And I can even edit that file if I want, or I can echo, this is some text to myfile.txt. Okay, and I can look at what's in myfile.txt, and I have this is some text. That's kind of nifty. If I leave this, typing exit, if I go into, now this is on normal gram, Debian from dhub. Okay, if I look at my file.txt, I can see it's 18 bytes. And if I look at what's in it, this is some text. So I can clearly write to this. So let's go back into it. Shell-w, okay. With the run and exec commands, you need -w as well if you want to be able to write to it. Debian from dhub. So that means I should be able to run apt update. Let's try that. Okay, this is working. That's needed to basically install packages into Debian. But now if I say apt install and I tell it to run install Vim, okay, it'll say, okay, I'll install Vim. And you hit enter on it and watch what happens. Okay, so it downloads files. Great, no problem. Okay, no locale set is because I just downloaded the pristine Docker image. I didn't set it. But look right here. Depackage error. Requested operation requires super user privilege. So if you are downloading an image from Docker Hub and you need to install stuff using the package manager or whatever Linux that is, so for Debian and Ubuntu, it'll be apt. If it's for Fedora or Red Hat or any of the RPM-based distributions, it could be RPM or Yum or DNF or whatever the command is there. But if it's Arch Linux, Pacman, etc., whatever the package manager is, if the package manager cannot tolerate not being super user, like Debian's, then you will not be able to install software unless you can use sudo on a machine that you have control of. If you don't have that ability, then submit a ticket asking for help. Okay, so we're kind of stuck now because if we wanted to install MPI or any of these other things, and if you're running Ubuntu, you'd get the same problem, and you'd install stuff. What do? Okay, well, ask for help or use a machine with Linux on, because then you can do the same command, just put sudo in front, and then you would be able to install it. That's not an option here. So instead, there are some Linux distributions out there that can tolerate installing stuff without having root perms. One of those is Gentoo, that compiles everything from source. There are some other Linux distributions that can tolerate that. They have special commands in that. But the other option is if you have an image from Docker and all the compiler tools and everything you need are inside the container, then if you are willing to manually build it by hand, then you can just manually build everything and do it that way. But again, that's a lot of work. So you want to use a package manager in some distribution. So I'm going to show to you that it does indeed work with Gentoo. Gentoo is not for the faint of heart, so if you need help with it, submit a ticket, and almost certainly that ticket will come to me because I use Gentoo myself. But Gentoo can tolerate not being super user to install software. So before I used Singularity and I said shell-w and I put the Debian directory name, okay? What was it? Debian from dhub directory name. But now I have Gentoo without sudo. I created that directory already, so I can have that and I can go into it. And I can hit enter like that. Okay? So now I'm inside of Gentoo. Now in Gentoo, the command that's equivalent to apt is called emerge. I can go emerge, okay, and I can tell it install. Let's take something, well, let's just tell it to install Vim, an editor. Okay, we'll do that. And it will figure out the details. You just have to wait for it to figure those out. I already installed it earlier, but I'll install it again. And you can answer yes. And then this will work without a problem. Okay, so this is a good thing. It allows you to install software, allows you to do things. Okay, I'm going to Control-C this. I don't want to wait for it. The other thing that's nice is with this ability to install software interactively like this is we can edit. So if Gentoo has special configuration files, so we can actually edit make.conf. And we can come up here, and if we wanted to, all the Compute Canada systems are at least Broadwell architecture. So we could tell it to compile everything for the Broadwell architecture, and you could even turn up the compile options -03 I added earlier, makeops-J8 to use 8 cores to build, and then you would be able to build everything in Gentoo optimized for the Broadwell architecture. So this is handy. So you'd be able to build stuff, put your software install and all that in there. One handy thing about using Gentoo is all the compiler tools and the build tool is already installed. So if you wanted to build things other than, operating system and package things and that, virtually all of your tools are there with the base Gentoo image. Now I just want to show you something. I'm inside the container, and I showed you earlier that the default version of GCC was 5.4.0. The version of GCC in this container is 9.2.0. Okay, it is not the same. So the GCC inside this shell in this container is not the same as the one outside. Recall the one outside was version 5.4.0. So when you run something inside the container, it's different than outside. And you say, well, okay, you want to run a command. Well, if I want to run GCC inside the container without interactive shell stuff, how could I do that? Well, instead of putting shell, you can put exec. And at the end of the line, you could put gcc-v. That's the command I ran inside the container. And if I do that, I get the output of the command inside the container, but I'm not in the container. It just ran that one command. Okay? So literally, you can put the command like that and do it. Now, understand if you compile something inside the container like this, even if you run the one command, you compile it produces something that will only run properly inside the container. So you'll have to run it inside. Okay? If you compile stuff outside the container, it'll run properly outside. Don't try to run it from inside the container. Okay? So every time you run this command, so the Singularity command, you need to think of whatever you put that you want to run, in this case, this command, it's running inside the container. It's important to remember that. Okay? So you can install software. So that's kind of cool. Okay? One last thing I'll show is if I'll show you building an image, you can build your own image. If you're doing it on your own computer and you have root, fine. There's a variety of things you can do that can't be shown on the cluster here. But one of the things you can show is if you have an image or you have a computer you like and it's the right setup and you tar up, tar is an archiving program like zip, if you tar up everything on the hard drive, okay, I downloaded from Gentoo's website their so-called stage 3 files, a minimal Gentoo install. So if you download that right off the Gentoo site, right here, that's a tarball, you can untar that into a directory. And to untar it into a directory, you can just go tar xf, and then you can put the whole name, put that there, and for Gentoo, you should make a directory first. I don't know, I'll call it temp, and tar xf, and that directory, okay, and you hit enter, and you wait a bit, and it will put a bunch of files in here. Now, I don't have root, so all of these files will be flattened out to my user permissions, okay? When that's done, you will have a directory that you can run Singularity, okay, shell -w, okay, and then you can go, I called it temp, like that, and you can hit enter and use it. That's how I made the Gentoo without sudo directory, okay? When you're done configuring software, so you have this shell, you did all your installs and all that, and everything's the way you want it, what you can do after that is run build one more time, and you can build, I'll call it gentoo.sif, and you can build from that directory, Gentoo without sudo, you can build a read-only image file of that, like that. Wait for it. When it's done, you'll have that read-only image file and if you don't need to ever write to it again, and that'll just stay the same forever, and then you can just keep using it as time moves on. So that, in a nutshell, is how you use Singularity. You got to get an image set up, and then you configure it the way you want. And then once you're done, then the rest is using Singularity in your Slurm scripts. And the Slurm script commands are just like what we did here, except they're your Slurm job scripts. So you put, I'll just Control-C this, get out of this, and Singularity. Okay. If you want to run a command, you could put exec. I'll do it with the image here. And I did GCC-V, so I'll do that it'll be quick. Okay, that's how you can do it. You can also use the run command there. Run special, if you do Singularity recipes. Normally you would just use exec, okay? Or you can use shell. If you're not wanting to make a .sif file, which is read-only, you want to have a read-write directory like this, you need to put the -w option, even when you put the exec. So if you put the exec like that, you'll have it. So in your Slurm script, you're going to use Singularity exec. Okay, so these lines need to be in it. If you're using MPI, you need to srun your command, and then whatever your command is over here inside that you want to run. You know, if you called your command a.out, then it would be that, and that would run your MPI command. Do not use MPI exec here. That will not work. Okay, so that's how you would run your commands inside the container. Finally, I will mention there are a variety of options that are important. One of them is a -E option. The -E option allows you to clean up the environment. For example, if you type the set command on your computer, you're going to see there's all kinds of environment variable set and everything else. So I'll call it gram environment.txt. So I'll put all the commands in there. And when you run Singularity, you inherit the shell of the parent program you're running. So if I'll just do exec here, and I'll run the same command inside of it, and we will see there's a difference. Okay, if we do set inside the container, my apologies, we'll do this with shell, so it'll be clear. If we do set inside the container, and you run it, you see the output's different. So we'll call this the gen2 environment.txt. Okay, we'll call it gen2.1. Okay, so we'll have that. Now there's another option you can throw in on these commands, -E, which tells Singularity to try cleaning up the environment. You want to keep some of the settings in the parent environment, but you want to clean it up as well. Okay, so if we hit that with -E, and then we go set gen2.2-env.txt. Okay, now we have 3 files. Okay, and you can see they're different sizes. Okay, Graham-env is approximately 28K. The second one we did is much smaller, 1K, and the first one we did is 18K. Interesting. Okay, so if we were to look at the second one we did first, because it's shorter, okay, let's come down here. Look at what path is. It's much shorter, okay? It strips out all kinds of stuff that can cause problems. What do I mean by problems? Well, let's look at the gen2.1 environment. Okay, and let's jump down the path. Okay, actually, without even jump down the path, we got all these CVMFS paths and all that. None of these are accessible from inside the container. Absolutely none of them. And if we go down the path, we have the shortened path line, but we got all these CVMFS things. None of these things are available inside the container. Because they're not available, there's no point in having them. They'll just cause problems for programs in the container. So whenever you're using any of your shell or run or exec commands, my strong advice is to use -E. If you need -W, fine, put -W. If you don't need it, fine. But make sure you also put a -E thing. So this will give you a clean environment so you can do things like install software and not have the pollution from the parent environment. Okay? Inside your container, you're almost only going to be mounting home, project, scratch, or local scratch. You will not be mounting CVMFS. If you need stuff in CVMFS, you should run that from outside the container in your job script. If you need it inside the container, you have a problem. You need to be able to mount CVMFS. So you have to put Fuse and CVMFS in there and Fuse mount CVMFS inside your container. So that's special configuration. Avoid that. Run the CVMFS commands outside your container, and inside your container, run the commands you've installed inside of that and have the best of both worlds. But to avoid headaches with your code, make sure you put a -E option when you run your Singularity commands, whatever they are. When you run shell, or if you use exec here or run here, make sure you put the -E. I'll leave it at that. I'll open up the questions, and if you're wanting to do certain things in Singularity, do say so. And typically, most users will install the software they want, OpenFoam or chemistry thing, and this and that. Some users want to install software that's already on our system. I say if you're doing that, you want to do that, use what's already on our system. It's already optimized. If you are taking that software that's already installed in our system and your goal is to modify it because you're doing research with it or something and change it around somehow, then Singularity is an excellent choice because you can modify it and it only affects you inside the container. We won't modify something globally on the system because it'll affect all users. So, but ask your questions like that, and I'll do my best to help you with an answer for them. Thank you.